this excerpt from the Ben and Ryan show, Ben Nadel throws out an idea on taking the SCrypt and BCrypt concepts of hashing multiple fields together and applying it to non-security data architectures.
The fact that the BCrypt and the SCrypt type algorithms store information right alongside the hash, like physically part of the same string, is so fascinating to me. It's the first time I had ever seen a technique like that used, and I'm now always thinking about where else that might make sense. And I don't have a great use case other than it's always itching in the back of my mind. Like, say, for example, you have at a company a policy that a password has to be rotated every 3 months, which, by the way, I think NIST says is a terrible idea. But let's say that it does. I almost wonder, okay, so maybe can I store the date that the password was last rotated inside the password hash itself? Or is that a terrible idea? And I'm stream of consciousness here. It's like you could argue that the hash of the BCrypt, you could take the version and the workload and store those as separate columns in the database as well. But it's very convenient for them to all be in the same place. And I don't know where to draw the line between co-locating data in a single field versus co-locating it across multiple fields. And there's not a specific question in there. I'm just, chumming the waters here in case there's anything interesting to talk about.
Yeah, and I think that gets into an architecture discussion as to how you're going to do your data modeling and why. So in the case of like BCrypt and SCrypt, the reason they embed all that data is because they don't want the verify function to have to change. So you can change it on the encoding side. So if somebody is creating a new account or doing a password reset, you can alter that code and say, I want to increase my workload, or I want to change something like the version of BCrypt that I'm using in there, and that gets encoded into the string. So now when you run your verifies, you don't have to have separate verify to check for that. It's built into the verify function for you. So you can take your encoding function and create those hashes and then make a change there and store the new hashes right alongside the old ones. And the verify function will continue to work without having to have a bunch of logic statements to say, well, this was the previous version and this is the new one. As long as you're sticking within BCrypt or within SCrypt, the verify function will read those parameters out and verify using the parameters that were used to create it. So that's why they're encoded in there, is just to make developers' lives easier. So we don't have to constantly be updating the verification code. It's just built into the algorithm.